Okay, so what I figured for today, and they also said, I feel pretty good about what we did for notes yesterday. Really shouldn't have been a problem. Sorry, those on the internet, I forgot to put my microphone in, so our sound isn't going to be great. But just deal with it. It's a short lesson today. But the others said they were going to continue with the graphing, and I feel good about what we covered yesterday. Input, say it. I mean, if you can't, from the two different graphs that we have, I want you to get like 3 points. For a cube root, it's the inflection point and a point before and after, and then get your curve to look like that. And then for the square root graph, just get three that work real nicely when you input, say it. So I should see like three specific points graphed. And I do have four graphs on our worksheet that I'll pass out to you after this. So just to review that. So I feel pretty good about that. I feel like we should have taken that. There's only two concepts, graphing a cube root and a square root, and be pros at it right off the bat. Now, if you want to write this down, because what's the square root of 4, everyone? That's simple. 2, but this is what we're going to do today. We're going to continue with talking about radicals, and then a format of a radical that you're going to have to be realized. And I'll teach this as if it's brand new. I feel like it might be. I don't know. I'm sure you've done the square root of 4, though, obviously. But we're going to do more than square roots. We're going to keep going and build on this. All right, so whatever. What's the square root of 4, everyone? 3, 2, 1, go. 2. What's the cube root of 8, everyone? 3, 2, 1, go. That is also 2. 2 times itself 3 times equals 8. So that's evaluating this appropriately. All right, and then this is not an I number. This just means we take the square root of 4 and get 2, and we slap a negative on it. Same thing with this. That's cube root of 8, and then you slap a negative on it. So don't think those are I numbers. As a matter of fact, not at all. With a cube root does that happen. All right, and then we should know this. What do you think the square root of 2 squared is? 3, 2, 1, go. It's actually 2 if you just do real quick. 2 squared is 4, and then the square root of 4 is 2. So what's the cube root of 2 cubed? 3, 2, 1, go. 2. Get used to this, because when we get variables going on, I got to turn off my phone. I got my friends. Yep, there they are. Starting a text string, and everyone's got, I like that. Like, approve, whatever. Yeah. Let's throw something else up here, though. What's the fourth root of 7 to the fourth? We could do this forever. 3, 2, 1. What's the answer? It's 7. All right, and that's what a fourth root is looking for. Something times itself 4 times. So really, what these are opposite operations. They like cancel each other out. Just imagine any index and any power that are equal. That number would come out free, whatever that number is. We're going to need that when we talk about variables. The idea of the exponents and how they deal with the index there. And now we got a problem. What's the square root of negative 4? To what? To I. This is an I number because I is equal to the square root of negative 1. It's the only way that we can answer these questions without really illegally, there is no number that multiplies by itself to equal negative 4. So that's what the mathematicians did. They created a separate I unit so that we could evaluate the positive number after getting that negative out of there. But people screw this up all the time. What's a negative times a negative times a negative? What's the answer to that? Negative. So what's the cube root of negative 8? It's not 2, it's negative 2 times itself 3 times. There is a huge difference between these two, and students don't get that a lot of times. I is the square root of negative 1 isolated because I don't want to look at it anymore because it's not evaluatable. Well, this does evaluate. So these are completely two different things. Students, don't get that sometimes. All right. So we're not dealing with I numbers, though, today so much. But just keep that in mind as we move forward. Okay, now here's where we're going to get into this. Okay, and then actually I'm going to hide a little bit that bottom page. We've already analyzed this. When it was the cube root of 8, we wanted something times itself 3 times. So that index, that's what this is called. The index is what we want, how many times something is. So what times itself? N times equals A is what this question asks. That is what that is in words. And the index has meaning. We must analyze that index and know what that meaning is. Hopefully they can hear me as I look away. That's where this microphone's really bad. And then I wrote something here for what I'm going to write below this. What if A had a power on it? Then just make sure you write that one over here. Because then the next thing I assume is going to be brand new. Hey, that's refreshing. No, they're jerk, Mr. Samuels. Hey, you should know how to do this kind of thing. Actually, that wasn't too true. That you should know how to factor. That's driving me crazy. All right, don't go there, Mr. S. Leave it alone. But quadratic formula was new, so I guess that took some practice. And then some of the other things from last section were new. Definitely quadratic formula. Probably solving by square roots is new too. So we'll count this as brand new. Here it comes. So this is truthful in math, and I'll prove this in one example on the calculator. Of course, we all trust the calculator, the Almighty. When you see a fractional exponent, I should stay over here so you can hear me, those that are going to be at home. This fractional exponent is exactly the same as that. That's what that means. And actually, this one has more value. When I have a to a power and then the nth root of it, the denominator of the fractional exponent represents the index of the radical. The numerator is the power on that particular thing, in this case, a. And that's just brand new. This, again, there isn't, and I don't get it. There is a memorization, and then you use it. And actually, I made a real simple worksheet today that if you walk out of here and still don't know this, there's a problem, all right? So we really got to get this down pretty quick. And I kept it numeric today. It does get a little crazier, and that's why we're taking it slow, plus we have the day, according to other teachers. Okay? So, first things first, we're not going to deal with that too much. We're going to deal with these questions, and we're going to make it verbal out there. Okay, so I do want to write this down. The fourth root of 81 looks like this, or it looks like this, 81 raised to the 1/4. This is true, and I'll prove this on the calculator. So that's writing it in both ways, but final answer, what times itself 4 times equals 81? Don't say 9. 3, 2, 1, go. It's 3. 9 is 3 times 3. Since 81 is 9 times 9, there's 4 3s in there. So 4 3s multiplied together equal 81, so therefore the fourth root of 81 is a free 3. And then as for the square root of 64, I asked for the cube root of 64. So the answer is not 8. What is the cube root of 64? 3, 2, 1, go. 4. And by the way, you had to know this. 64 was used quite a bit when we did sum or difference of cubes factoring way back in chapter 3, if we call it chapter 3, topic 3. We're actually in topic 4 in the math 3 book, so this is going to be confusing. We just finished chapter 4 in your mind, what I called the solving quadratics chapter. And that was a little bit of chapter 5 in the math 2 book. Now this is chapter 4 in the math 3 book, so that's why you see chapter 4 again up at the top of the notes. Very confusing. Really don't like not having a book that's real solid that we can go through chronologically or in order. I don't know if chronologically is the right word there. What's the answer for the next one? 3, 2, 1, go. 2. 2 times itself 5 times equals 32. So the fifth root of 32 is a free 2. All right, so it's just evaluating today, looking at and understanding radical notation, and going from there. Okay, let's do verbal responses if you don't want to write this down. Fourth root of 16, 3, 2, 1, go. 2. Cube root of 125. Take a wild guess. It's a nice even number. 3, 2, 1, go. 5. These are numera people. If you're sitting around looking at everyone else going, where did you get that answer from? You got some numeracy thing going on here. Because 5 times 5 is 25. 5 quarters when you pay for lunch is $1.25. So 5 times 5 times 5 equals 125. Ooh, this is a tough one. Let's see how many people know this one. 3, 2, 1, go. Nice. See, 243 is 81 times 3. 3 times 80 is 240, and then add a 3, 243. So this is 3 to the 4th times another 3. This, we already did the 4th root of 81, so maybe a little connection there. So yes, that is 5 3's multiplied together. So the 5th root of 243 is 3. So that gets a little bit large. You can figure that out, though, I would expect in this class. Okay, now here's where we're getting down to it. It does say evaluate. On our first questions, though, it just says change it to a radical, and then you don't have to evaluate. So I am going to do that. This does mean 36 to the 1/2 power, the square root of 36 raised to the first. In both cases, these are never written in a general question. These are the given. Like you don't have a right to the first power, correct? Isn't that the invisible power? Well, the invisible index is 2. When there is no index there, it means square root. And we already know that. You've already answered square root questions before. All right, so, but I'm writing it there just to emulate what this question is doing. 2 on the bottom is the index, 1 on the top is the power. By the way, what's the answer? What's the square root of 36? 6. Okay, and that's it. All right, so kind of writing it and then understanding it from there. Now, I will tell you this, fumble. This is, I'm going to write this real large. Actually, I'm going to write this here. The cube root of 8 squared. Now, I'm going to tell you right now, these are no calculator questions. I had someone punching their buttons last hour. I go, what are you doing? You're actually just copying screens, and therefore you'll never learn this index thing. And this is a big problem with the calculators in general, why people are innumerate. All right, really is using that calculator too much, especially with the fraction button. But anyway, that's me going on a little diatribe there, which is a negative rant. That's how you want to do it, because if it's no calculator, you want to bring the number down first before you square it. So you want to cube root it first and then square it after. So you have an option to do either. No calculator, that's what you want to do. By the way, what's the cube root of 8, everyone? We've said it. 3, 2, 1, go. And then what's 2 squared? That's how you do this without a calculator. You do the rooting first, then the squaring. Ain't no thing, anyone? Chicken wings. Now, this one is not no calculator. So why don't you just say it's calculator, Mr. Samuelis, without the double negatives in English. All right, and this is the time that I am going to show you where those buttons are. So I did that last hour. I don't know why I was having such a hard time last hour seeing this question while I was looking for the typing. Okay, pay attention. Okay, but then I'm telling you right now, you're not touching your calculator the rest of the day. All right, but it is in math. So you hit the math button, and it's actually right there, number 5. If you have an old 83, well, when you hit this, X root comes out on your screen. That means you have to type 5 first, and then X roots. Anyone have an old 83? An old, like 83, just period, that's it? So you would have to hit 5 first, then X root. Right, and then X root comes out. But look at what we get in our fancy calculator. We actually get this to be blinking, ready to go to make the index whatever I want. You have to type 5 first, and then it says X root next to it. Actually, I could probably turn my calculator into that mode to show you. 3.5. But let me finish this off. Caret 4. So I do see those great old-fashioned calculators. They're still awesome. From the 90s, the TI-83 was. Caret, here's what I'm showing you now. 4 divided by 5. The idea that the fractional exponent rule does equate to radicals, seeing that we get the same evaluation here. Those that have the 83 regular, I'm going to see if I can do this. I forget. Maybe I don't know. Mode. No, I don't think it's mode. Math print. Maybe it is. Yeah, okay, I can go classic. Just want to see if this happens. Hit enter. And then when I hit second quit and I hit math, I just want to see if it does do 5 as it used to. Yep. So what you'd have to do is insert a 5 in front, second insert, and then that is the fifth root. Oh, for gosh sakes. That's incorrect. Sorry. So I'd have to hit 5 first, then hit math x root. That means fifth root in the old calculators. Okay? And then 3.5 raised to. You might need parentheses, though. Probably not. I think you're good on that. Now my face is in the way here. Done with the calculator anyway. Go away. Okay. All right. So that's a calculator question. I do have a couple other things to do, but maybe we can just answer these like this one. What's the answer for this one? 3, 2, 1, go. 5. It's not 12 and a half. I'm going to get goofballs that do that, making up their own math. Oh, my cat class. They just make up all these things. And just my cat class driving me crazy. Fifth root of 32 squared. We already answered what the fifth root of 32 is. What is it? 3, 2, 1, go. Oh, no, we don't know the fifth root of 32? 2. Okay, 2 times itself 5 times equals 32. And then 2 squared is 4. Okay? All right, couple more. I got this one, and I got to make up a couple because I forgot I threw a rule on our worksheet that we're going to need to remember. All right, but this is not a fourth root of a negative. You are fourth rooting 16 and then cubing, and then the final answer you slap a negative on it. All right, so this can be equated to PEMDAS. You got to deal with the exponent before you deal with the multiplication, because this is like negative PEMDAD. What? That's like negative 1 times. All right, so it is a PEMDAS violation if you think that negative is part of this this situation. It is not. This actually would look like this, and then it's the fourth root of 16, and then cubed, and that negative is still outside from there. Okay, what's fourth root of 16, everybody? 2, and then it's 2 cubed, which is 8 with a negative on it now. Okay, but here's what I forgot. Didn't forget, but when I was making the worksheet, I put these kind of questions in here. Someone last hour seemed to have known this. What is 2 to the negative second power? First of all, it's not negative 4. Negative numbers have nothing to do with negative exponents. Does anyone know what the answer is? I'm interested to see if anyone knows. Go ahead. Ethan, right? No, what's your name? Sorry. Owen. I was close. Ethan, Owen. There's some vowels and an N. All right, but what is the answer? Oh, you were close. It's actually 1 over 2 to the second, which is actually 1 what? 1 over 4. So you did the fraction thing. I do like that. But it's not 1/2. It's 1 over 2 squared, which is 1/4. How many people have seen the negative exponent rule? And we know that it flips like this. Okay, well, if you haven't, just get it down now. I'm probably 2 days going to explain where this rule comes from. So hopefully there's more solidification. But the bottom line is this is a rule that you have to have memorized. Again, there's no I don't get it. You just do it or you don't kind of thing. So that's what that means. I'll explain where this comes from in at least 2 days. But then here's the kind of question you're going to end up with on our worksheet. Oh, I guess I'll do 16 again. And I think it's very similar to one we just had before. But what about 16 to the negative 3/4? How do I go about doing that? Well, it's actually the same as this. What a negative exponent. And by the way, I did this in my class too. What is 1 over 7 to the negative second? Sorry, I know I'm scatterbrained a little bit on that. And when you have a negative exponent on the bottom, it actually does flip to the top. So actually, and you could type these all on your calculator. You could do the caret button and prove this by getting 0.25. And then this one is actually 49. Because 1 over 7 to the negative second is 7 to the positive second put up in the numerator. All right, so it does flip both ways, the negative exponent rule. So that's actually true. All right, but then how do I deal with this? So you might have flipping in your mind, but what it is this, you don't flip the exponent. What you do is this whole thing that's raised to a negative power flips down to the bottom and becomes a positive power. Just exactly what Owen said. All right, knowing that 2 to the negative second is 1 over 2 to the positive second. It just happens. All right, so that's what you got to know about that. And then this is the fourth root fumble of 16 raised to the third. What's fourth root of 16, everybody? 2. What's 2 cubed, everybody? 8, but this is 1 over 8 because of the negative exponent rule. Okay, so kind of leaked the negative exponent into our notes today, so therefore you got to deal with it in these questions. One little added thing. All right, so I kept today to only numbers. Tomorrow we'll get into the kind of ugly world of square rooting with variables. Really do remember this, though. It really does apply to what we had over here. Trying to go up here. Like the fourth root of 7 to the fourth is a free 7. That concept is how we're going to tackle variables when we do that. But anyway.